All right, let's talk about a huge challenge facing pretty much every big business out there. How to get out from under the weight of old, expensive, and super complex IT. Today, we're going to dive into something called Oracle Cloud Infrastructure, or OCI, and see how it was built from the ground up to solve some of the toughest problems in the enterprise world.
But let's start with the big question, the one that kicks this whole thing off. A lot of companies have found that moving their most important, most performance-hungry applications to the cloud, well, it's not always a walk in the park. So why is that? Why do these critical apps sometimes struggle? This is the core problem we're going to unpack today.
You see, to really understand the solution, you first have to feel the pain. And for so many companies, the modern IT challenge really begins with the gear they already have sitting in their own data centers. We call this the legacy IT trap. I mean, think about it. Building and running your own data center is just a massive drain. The costs are always climbing. Managing all that complexity is a constant battle, and when your team needs new hardware, you're stuck in these procurement cycles that can literally take months. This doesn't just hurt the budget, it grinds innovation to a halt.
So this pain is exactly what's driving this huge shift to the cloud. And to really get what makes OCI different, we need to zero in on the most fundamental layer of the cloud world, infrastructure as a service, or what everyone calls IaaS.
So what is IaaS, really? The easiest way to think about it is like a division of labor. The cloud provider, they handle all the physical stuff. The servers, the storage, the networking, and the virtualization that makes it all hum. You, the customer, get to control everything from the operating system on up. It's your apps, your data, your middleware. Okay, and here's where the story gets really interesting. The cloud isn't just one monolithic thing. There's a huge difference between the first generation of cloud platforms and what we now call the second generation. And believe me, this difference is everything when it comes to those demanding enterprise workloads. This table really nails the generation gap. So first-gen clouds were built on what's called a multi-tenant model. Think of it like an apartment building, where a bunch of different customers are all sharing the same physical server. This is what leads to unpredictable performance and that dreaded noisy neighbor problem, where someone else's heavy workload suddenly slows your application down. A second-generation cloud like OCI was built differently from day one. It offers single-tenant, dedicated machines so you get total performance isolation. It's really about getting the power of your own private data center, but with all the flexibility of the public cloud.
So how did OCI actually do it? How did they build a platform that could deliver this kind of performance and control? Well, it all comes down to a couple of really smart, deliberate design choices.
First up, bare metal. This is the ultimate answer to that whole noisy neighbor problem. You get an entire physical server dedicated only to you. No sharing, and just as important, there's no hypervisor tax. That's the performance overhead from the virtualization software that normally eats up a chunk of your server's CPU and memory. With bare metal, it's all yours.
So how do they get rid of that tax? This is the clever part. It's a technique called off-box virtualization. Instead of running the virtualization software on the server itself, OCI moves that job onto specialized hardware inside the network. This is a total game changer. It means the server can dedicate pretty much all of its resources directly to what you're running, giving you that true, uncompromised bare metal performance.
And then we have to talk about the money. With OCI's private connection service, called Fast Connect, there are no extra charges for data transfer. Let me say that again, because it's a big deal. Data egress, that's moving your data out of the cloud, which can get notoriously expensive with other providers, is not charged over this connection. For any company moving a lot of data, this can be a massive, massive cost saving.
Okay, so the architecture sounds great on paper, but what does it actually mean for real businesses? Let's look at the proof, because the performance numbers are pretty incredible.
Just take Maritz, for example. They were dealing with a crippling 72-hour disaster recovery process. 72 hours! I mean, that's 3 full days of downtime risk. After moving their core systems over to OCI, they slashed that window down to just 4 hours. Their summary says it all. For them, OCI was simply better, cheaper, and faster.
Or how about this number? 60. 60x. That is the performance boost Cisco saw when they moved their Tetration security platform to OCI bare metal. They were hitting a wall with the noisy neighbor problem on other clouds, getting maybe 5 to 10% CPU utilization. OCI's dedicated resources completely changed the game for them.
Just look at that jump on the screen. It's wild. On other clouds, they were paying for all this processing power they couldn't even use, just hovering around 10% utilization. On OCI, that shot up to an incredibly efficient 75%. This wasn't just a small improvement. This performance gain actually allowed them to offer their service to a whole new market of smaller businesses. And it's not just about raw speed. It's also about value. Altair, a company that makes these really complex engineering simulation tools, found they could get up to 25% better price performance on OCI. What did that mean for their customers? It meant getting critical design results faster and ultimately getting their products to market sooner.
So these stories aren't just isolated wins. They all point to a really clear pattern. Let's pull these real-world results together and look at the key advantages that really define the OCI platform.
Now, a huge one, and this is an exclusive advantage, is the autonomous database. It's built on this incredible idea of removing human labor and human error. It's self-driving, using machine learning to handle all the tedious admin stuff. It's self-securing, patching itself against threats while it's still running, with zero downtime. And it's self-repairing, automatically bouncing back from failures to keep you up and running.
This brings us to the SLA, the service level agreement. And honestly, this is a pretty bold claim. Most cloud vendors only guarantee availability, basically that the service will be switched on. Oracle is the only one offering an end-to-end SLA that also guarantees performance, that it will be fast, and manageability, that you can actually control your services when you need to. That's a huge statement of confidence in their platform.
So let's bring it all home. The OCI advantage really boils down to these core pillars. You've got consistent performance for your most important apps. You've got better economics, driven by those predictable networking costs. You have openness, so you can avoid vendor lock-in. You have security that's built on a zero-trust architecture. And finally, being Oracle optimized means you get exclusive access to powerful tools like the autonomous database.
And that really brings us to our final thought. As you think about your own IT strategy, just ask yourself this. How might the predictable, dedicated performance of a second-generation cloud impact your most critical applications? And maybe even more importantly, how could it unlock your potential for future innovation? That's definitely something we're thinking about.